Hey everyone, I'm Priddy here with Fiveten Giant. We're here at Adobe Max 2020. Stop. Priddy with Fiveten Giant. We're here at Ava. No. Ava, no. Honey, she's trying to press the power button. No, I don't care what we have for dinner. Anything's fine. Hey everyone, I'm Priddy, founder and CEO of Fiveten Giant, and we're here at Adobe Max 2020 Pandemic Edition. By here, I mean my makeshift dining room office in Southern Indiana. And by Pandemic Edition, I mean when your daughter constantly wants to press that little glowy power button on your PC while you're recording, your dog wants to bark at everything walking by, your significant other needs more things than usual, and you don't have to wear pants during the presentation. So today we're going to be going through dealing with CAD models in Cinema 4D. Now, it's important to express that when I say CAD file, I don't always mean files coming from engineering software such as AutoCAD, SolidWorks, Rhino, and applications of that nature. I'm also talking about 3D scans, photo scans, any non-uniform, non-polygonal mesh, try to bring over from another program into Cinema 4D. These imports are often far from ideal in terms of trying to animate them, especially UV unwrapping and texturing. So I want to thank Dell, first of all, for the sponsorship of this presentation, and they were kind enough to provide me a super tricked out precision workstation that has made my life so much easier in doing these large CAD model conversions. So if you want to take a look at what I'm talking about here on my screen, I have a project that I actually worked on internally for Dell. And if you take a look, if I make sure that my display garage shading lines is on and I select my object, you can see the kind of topology and mess that you're going to be dealing with when you're working with these files. And what I'm going to try to go through today is my tips, tricks, and workflows that I've learned over the past decade on dealing with these and prepping them for what you need to do to them or with them in Cinema 4D. All right, so we can't really dive into the workflows until we cover the CAD Import Settings. So I've started just this simple connector file import, and it's a SolidWorks assembly file. And you can see that it pops up this nodal interface called Import Settings. Now, this is where your power and control come from. This is your translator from a native CAD format into something Cinema 4D understands and that you yourself can use. So I'm just going to gloss over some of these, or actually most of them, and I'm only going to dive deeper into the ones that I actually might change. So I've got help.maxon.net up here, which is an extremely useful resource for anything you need to understand about Cinema 4D, and I've got their CAD import help page pulled up. Now, about halfway down, you can see that Cinema 4D can open IGES files, step files, JT, SolidWorks, and CATIA. In addition, I also know that you can open DWG files as well. So I'm not going to cover the nodal interface that pops up for each of these file types because honestly, they're pretty much identical. So let's go ahead and dive into the SolidWorks import settings. And let's start going down the list. Original units, this is all related to the scale. I leave this checked. I can change the scale later. You're welcome to play around with it if you choose. Geometry, this is your meshes, the things that you need to bring over. So leave this on, it's on by default. Splines can come in handy when you're dealing with DWG files and you need building plans and things like that to come over. And those are typically 2D drawings in CAD, and they'll come over as splines when you need the measurements and the proportions and everything laid out. That's where you'd want your splines. I'll leave it on by default, and I just kick anything out of the object manager that maybe comes in that I don't need. Now, your instances, your options for instances are none, instance, and render instance. All instances is going to do, I shouldn't say all it's going to do because it's super important. The instances, imagine you have 100 screws. They're all the same and they're in the CAD file you're importing. When you have this set to instance, instead of importing 100 screws, it imports one as a mesh and the other 99 are instances, which just make it a lot easier to move around in your object manager. And in addition, as an added benefit, if you need to change those screws, all you need to do is change the main reference mesh and the other 99 screws will all change with it. A render instance gives you the same benefits of an instance, but it also reduces the memory allocation needed to do the rendering. So instead of loading 99 or 100 screws into your video card memory, if you're using Redshift or Octane or something like that, it only loads one. I always keep this set to render instance. Helper and hidden objects, more for the CAD engineer or CAD artist. Your normals, your normal tag is just a baked Phong tag. If you start to see issues with smoothing or shading on your model, you can always delete the normal tag and use a Phong tag. Display colors, layers, and materials. These are all preference. UVs, leave that checked. You want your meshes to have a UV tag so that you can change a projection or so that it can house any sort of custom UV mapping you may do. Visibility, ignore this. Modifications, by your combine attribute by topology, leave this by topology. If you see here, you have none original bodies by topology, by color, and by layer. By topology is recommended by even Maxon, and I echo that sentiment because it creates meshes based on their shared volumes. And anything else, when I was testing out these other options in the infancy of the CAD importer, the other options sometimes gave me what should have come over is maybe 1,000 meshes in a bunch of instances as one single Frankenstein mesh that I had to manually separate some things off. Or you could end up with the opposite effect where you have one mesh that should be one mesh, but it's actually separated. The curvature is separated into its own meshes, and it might come in as 100 meshes instead. So go ahead and leave this by topology. That's going to be your winner. Swap Y and Z axes. You can mess with the axes once it's in. Heel and stitch. Leave these off. Really, the only time that you'd ever want to mess with them is if you start having a lot of holes in your mesh. But generally leave these off, and you can go through the help if you want to learn more about those specifically. Optimize hierarchy is just going to make sure that your object manager is, nicely organized and parent-child relationships and such. Scale-based tessellation is going to give your prominent, your larger heroic objects more detail, and your smaller, maybe more insignificant meshes less detail. I leave this off. I don't want the program to decide that for me. I'll make those decisions. Now the detailing, we will just cover that a little bit, and I'm going to use Maxon's help as a reference here. Now, I generally always have this set to original. Sometimes original can come over faceted, in which case you may need to look at medium and high so that your curvatures have a higher fidelity if your camera needs to get in on those areas tighter. But case in point, this Dell laptop that I worked on for them, I had to use the detailing set to high, and it took 20 to 30 minutes to import this model. Now, so you need to understand that messing with the detailing or the heel and stitch could have quite large ramifications on your conversion times. On my personal computer, like I said, 20 to 30 minutes for this laptop. It wasn't until they sent me a Precision with double the RAM and a crazy processor in it, I was able to get this down to 7 to 10 minutes. Your max length is going to be if you have this set to custom, and I'm not going to go over that. You're welcome to jump into the help and maybe play around with this on your own. But, these are very special use case situations, and I have run into situations where I've needed it before, but generally not. So that pretty much concludes our import settings. Let's go ahead and get to the meat of the workflows of dealing with CAD models. All right, so diving into our first issue, we're going to be talking about Phong Angles. Now, your model from CAD will come over with a normal tag. So generally, if you start to see these issues with the normal tag, you want to delete your normal tag and then just add this Phong tag. Now, your Phong tag, without going into too much detail, basically your adjacent polygons, for instance, these two, as long as they're under 40 degrees, it's going to smooth across them without creating an edge at this point where they meet. So what I want to do is fix this edge here. Now, I know that's a problem, and it's not just a visual error within the viewport, because when I send this over to the renderer, and I'm using Octane here, you can clearly see that that's going to be a problem in our final. So what we need to do is we need to fix that. So the problem lies in the fact that these edges here are broken. They're ignored from the smoothing algorithm. So what we want to do is hit Control-AR on a keyboard. And the reason I'm selecting them all is because I know that this is a uniformly smooth mesh. There's definitely, or at least I don't want any breaks in it. So I want to catch any other edges that might have come in wrong as well. I'm going to right click and I'm going to use the Unbreak Phong shading. Now, if I go back to my model mode, you can see that that's fixed. And you may run into this bringing in CAD models on any sort of curved surfaces. And if you see something like that, something that looks like an error in your shading or your smoothing, then that's usually the culprit, and that's how you fix it. Now, if we go over to our render to make sure everything's kosher, indeed, it has been fixed, and we can send this little metal ball off to the client and invoice them. All right, so next issue we're going to talk about is normals. Now, I'm going to go into this assuming that you know what a normal is, but let's just take a look at what we've got on this model. So in Cinema 4D, if your normals are facing the wrong direction or you're looking at the backside, they're blue. If they're facing the correct direction, you'll see orange on the outer faces. Now, you want your blue side to be facing the inner volume of the mesh. Think of this as like putting your shirt on inside out, which is generally not okay unless you're in a pandemic and you want to wear it 2 days in a row. So what we need to do is we need to flip all these around. But first, let me show you the ramifications of actually having the normals facing the wrong direction. Now, some renderers will be a little more lenient with this than others, but let's take a look at what Octane does so we can get an idea of what we're looking at and what we see when we have this issue. So I'm going to go ahead and send this over to the renderer. And as you can see, we have like what looks like a high index, almost a metallic look all around the Fresnel edges of this glass. So I know I have my my polygon selected. So I'm just going to right click while the render's running and reverse these normals. Now you see we've got our shirt on the right way. Everything's facing correctly. Let's go ahead and stop the render. And you can see our orange side of the polygons, the correct side, is facing outwards. And our volume is contained with all our blues facing inwards. So another issue that you could run into with this as well, and I've had it happen, especially with CAD models, is a portion of the normals are facing the wrong way. So let's take a look at what you see when you get that. Now, the renderer doesn't know what to do, how to bend the light correctly, because it's not hitting the correct side of the surface first. So let's go ahead and show you how to fix just this issue. Now, as you can see, if I hit Control A on my keyboard, all my polygons are selected. You can see there's just a patch that are facing the wrong way. Now you can manually select these and reverse them, or you can use a command called Align Normals. So what this is going to do is take the average of the normals of the model, and if it sees the majority facing one way and a minority facing another, it will fix the minority. So we're going to use align normals, and that's going to be fixed and correct. All right, on to a new set of problems. This block here is actually going to represent a few different things and scenarios that I deal with in CAD, and the first of those being optimizing the points. Now, one of the first things I always do when I bring in a CAD model is I optimize the points, and let me show you why. So one of the things that can happen when you bring these guys in is the points may not actually be fully welded together. So to illustrate this, let's go into our live selection tool, make sure only select visible elements is turned off. I want to go into the options menu of the viewport, configure or shift V. And I want to make sure in the HUD section, the selected points, edges, and polygons are all checked. This is going to give me a UI element in my interface that will show me how many points I have selected or edges or polys. So let's just select this corner here. As you can see, I have 9 points selected. That causes a problem. Let's turn on this bevel deformer that I pushed on here. And I'm not going to go over the bevel deformer, but this is going to create roundings based on angle thresholds. And you can go through the help and learn a little bit more about that if you're not familiar with it. But this is important because you want rounded edges. Nothing in this world has a sharp corner. So let's turn on our bevel. And we can see that in some spots we're getting the bevel. And let me change this to 0.2. In some spots we're getting a decent rounding on the edges, but on other spots it's just falling apart. And that is a direct result of points not being connected and the mesh not being completely closed off. So let's turn this bevel back off, go back into point mode, select our mesh. You can see even here we have 4 points, 9 points. So to fix that, we're going to hit Control A on our keyboard in point mode, and we're going to right click, and we're going to use a tool called Optimize. I'm not going to click on Optimize. I'm going to click on the gear. And the importance of that is because this tolerance level is by default set to 0.001. Now, in my world of working with small connectors and things like that, these 2 points here, they could actually be within this tolerance and weld these together. And I need this, this bridge of polygons here to still be there after Optimize. So I'm going to just throw in an extra 0 for good measure. Now let me check my points again. If I click on this point, you can see now I only have 1 point fixed. Let's turn our bevel back on and go into model mode. I'm still having issues on some of these corners, but you can see here that it's a direct result of the triangulation of the model. So now we're going to use the untriangulate tool. So I select my mesh, go into polygon mode. I'm going to hit Control A on my keyboard to make sure all polygons are selected. Right click and use UU on your keyboard or the untriangulate tool. And this will bring up an interface in your attributes manager for the untriangulate tool. I'm going to click apply. And that's going to remove the triangles. Now, this is not always going to give you such a clean result, not by a long shot. A lot of times you may have to set this to create ingon so that you can get all of the mess of triangles gone so you have a workable surface. We're going to leave create ingon off. And you have an angle here where you can adjust the angle at which it looks at when you start to have curved surfaces that you want to try to untriangulate. So we're just going to leave this low for now because we don't have any curved surfaces. So now that our mesh is untriangulated, let's go back into model mode and let's turn our bevel back on. As you can see, we have a much better result. And you may be wondering, why do I go through all this trouble in order to put a bevel on here? And let me just illustrate that by sending it over to Octane so that you can see the importance of having rounded edges on your models. So these are kind of large roundings. You may deal with models that work with something quite a bit smaller, but even if you go really small, you can still see that rounding, and that's still picking up highlights from the lights and giving the model depth. And that's what's important here. For realism, nothing in life has a perfectly sharp corner. So let's just go ahead and turn that off to illustrate. You can see that this is boring. This is very unrealistic. You have sudden changes in your shading. As soon as you flip that bevel back on, you've got much better, much more realistic results. Now, here's the issue. You will not always be able to put this bevel tool on a model because sometimes you're going to get a very stubborn model. You may not even be able to untriangulate it. Now, this is where I use a tool in most renderers called triplanar. Or I'm sorry, not triplanar, rounded edges. Triplanar is coming up next. My mistake. So I'm not going to go over how to deal with rounded edges I'm going to try to leave this fairly render agnostic and just go over the concept. So let's go ahead and send this over to our render and let's put a similar radius to what we had on the bevel tool. And now you start to see that rounded edge show up. And we're faking it essentially, because if I scoot in on this, you can see that these edges are still pinpoint sharp, but I know I'm not going to be that close on it. So I've just saved time in untriangulating, in massive optimizations, mesh checking, and cleaning the mesh up so that I can make way for this bevel tool and just use the rounded edge shader. This is a huge, huge, huge benefit to dealing with CAD models. Very important to have in your toolkit. So understand how your renderer deals with it and make sure that you're using it. All right, so sometimes you've tried all the other methods that I have mentioned, which are not even close to all the ones available to you, but just the ones that we have time to discuss. And you really just can't get that model cleaned up enough, or you have too much curvature on it. You can't pull a good untriangulate on it. You can't or don't have time to do a UV unwrap on this to lay textures across this properly. So let me talk about triplanar textures and why they're important. So I'm not going to go into too much detail about how to set up a triplanar texture for specific renderers. I want to keep this semi-render agnostic, but I am using Octane here, and that is what I'm going to use to illustrate the importance of triplanar textures. So first, let me go ahead and set this. Let's see, let's go to our node editor, and we have our triplanar node. So what I've done here is I have green set to the Z plus and Z minus on the mesh. I have blue set to the X plus and X minus, and gray set to the Y plus and Y minus. And basically what's going to happen here is I'm going to blend those together so you no longer see these seams. Now I'm using colors here to get a better illustration of what it is I'm trying to show, but I will show you a more real world example. Now as I start to up this blend angle, you're going to start to see those seams disappear and those angles blend into each other. Now this is going to allow you to use a form of cubic mapping. It's not going to require you to have UVs laid out, and you're going to be able to get a pretty good result. So this is a really quick way to texture your model when you can't pull a good UV map, when you can't clean it up right. So let's take a look at a more real world example of that. And let's just load up this granite texture I have, set our blend angle back down to 0, and let's go ahead and make that our active material. Now, this material specifically looks okay, but depending on the size and patterning of your texture, you may start to see these seams much, much worse. And they're going to be in the exact same spot that you saw it on the colored mesh. So let's go ahead and up that blend angle and see what this triplanar can do for this type of situation. Now you can see it all across the upper arm here, and this is happening on the back as well. Think of this as a 6-sided cube, and that's how it's texturing it. So now we want to blend this angle together, and as we up that blend angle, you're going to start to see the sides blend into one another. The top material and the side and the front material are going to blend together across that angle, and you get a much better result. And this is a huge, huge thing that I use in my toolkit, and you should too, in order to pull those quick deadlines and deal with those very difficult, hard to texture models when you seem like you're kind of at your wit's end in how you're going to get them textured and get a good look out to the client. All right, so we only have time to talk about one more thing, unfortunately. Now, this is another thing that I deal with quite often, and that's when your meshes come over and they're not supposed to be a single mesh. Now, originally, when this was created in CAD, these tails were separate pieces, and you can kind of see those start to bleed through. If we look inside the model, these are not actually, they don't share the same internal volumes within themselves. So they should have come over as separate objects. And most likely during the import process, they weren't set to by topology. So let's go ahead and show you guys how to fix that. One tool I want to show that's extremely helpful, and not only for just this, is the select. Under the select, let's go ahead and go to polygon mode. Under the select menu, there is a tool I use all the time called the fill selection. Now, it's not only just for this, but I find it to be very useful in this situation. It's also UF on your keyboard. So this is going to select the meshes that are essentially their own volume. They're not connected in any way to this body. These tails are not, and these pins are not connected in any way to the body. The pins and the tails aren't connected to each other. So it's finding the individual meshes. And this is a great way if you need to just separate out a couple things. And I use this all the time. So what you could do technically is you could select all of these manually, and you could do a selection set, and then just select the material that you want on those pins and then drag your tag to it. That would work, but we're not going to do that. We're actually going to do something a little more time saving and efficient. So this tool that Billy Chicken actually put me onto at one of the NABs, it was a year or two ago. I can't remember. Pandemics, you lose track of time. But it's called Polygon Groups to Objects. So Cinema 4D already knows, because this fill tool clearly selects the separate meshes. It already knows that these are separate meshes. So all we need to do is hit Shift-C on our keyboard, which loads the commander, so that you can get to any tool in Cinema 4D very quickly without having to go through menus. And I already know it's called Polygon Groups to Norm or to Objects. So I'm going to double click this. Actually, you know what? First, I'm going to make sure I have all my polygons selected and hit Shift-C. And then I'm going to use Polygon Groups to Objects. Now you can see here that we have a lot of new meshes. Now I'm going to go ahead and tell you that these are all of your meshes that you need. And this top parent mesh is just an empty mesh. So we're going to hit Alt-G with all our extra meshes selected, which is going to put that into a null group. And we're just going to name that connector with a capital C and O. And we are going to delete our single mesh. And now we're going to take a closer look at what we have here. So let's go ahead and middle click our connector, and then I'm going to use another very important tool, and that is the axis alignment tool. So I'm going to go to mesh with all of my meshes selected, and I'm going to go to axis, and I'm going to center axis 2. This is going to center the axis to the average of their size, essentially, so that the axes are in the right place. All right, so now what we're going to do is start clicking these meshes and figuring out what it is that we've got here. We can see that our pins and tails are kind of mismatched, and they're now in no clear organization. We know clearly that this is our body because of object highlighting. So we're just going to name that body real quick. And then we're going to go into the side view. We're going to use the rectangular selection tool, and we're going to select all our tails. Make sure nothing else got selected up here. And then we're going to right click in the object manager and then go to connect objects and delete. So now we know these are our tails. And then logical deduction tells us that the rest of everything else that's in here belongs to the group of the pins. So we're going to right click after selecting those, connect objects and delete. Now we know the tins are supposed to be silver, or tin actually. And let's get rid of that. I'm sorry, I made a mistake there. Let's get rid of these. Let's actually name it. How about we name it pins? That way we're not confused. Always good tidy housekeeping in your object manager. All right, we know those are supposed to be gold because the client said so. We know these are supposed to be tin. The client said so. And we know this is supposed to be black plastic because I said so. So let's take a look at what we've got now. And we're going to go ahead and send this over to the renderer. I've already got rounded edges set up on these materials. And you can see that I have my connector and I have the body, the tails, and the pins on their own mesh. You can have them separate if you need to, but I like to keep things together unless you need to animate separately. So that pretty much concludes our dive into dealing with CAD models and C4D. I want to take this time to thank Dell, the sponsor of this spot, as well as Maxon. And come visit me at 510giant.com if you have any more questions. There'll be a question and answer session. I'll be happy to cover more things that I do to deal with CAD models. And feel free to reach out to me via social media or email. And I hope this has helped. And you guys have some insight on how to deal with these CAD models a little better in cinema.